Alarms howl in the observatory like a smoke detector that hates optimism. Telescopes swing. Astronomers sprint in socked feet, spilling coffee that has already given up on being warm. The sky looks fine. That's the problem. Too fine. Like a hospital corridor at 3 a.m., freshly mopped. No witnesses, no pulse. Somewhere between now and a number so big it gives calculators stage fright. Every star has gone quiet. No bang, no grand curtain call, just the greatest light show in history ghosting out like a TV left on mute. Check the photometry. Flat line. Spectra? Dead air. Every constellation is there, but it's the museum version. Labels. No life. Welcome to the late universe, the black dwarf epoch, where suns retire not with fireworks, but with paperwork. Slow, boring, relentless paperwork handled by thermodynamics, the accountant who never sleeps and never laughs. Here's the hook. Stars die in silence. Not because they're shy, because physics is patient. The universe doesn't slam doors, it lets hinges rust. The future is a room-temperature graveyard, where the headstones are carbon-oxygen diamonds the size of planets. They used to be suns. Now they're cosmic ice packs. If you listen closely, you hear nothing. Silence so deep, it trips your fight or flight, and then makes fun of you for picking flight in a vacuum. Black dwarf theory is how we get here. Take a sun-like star. Give it billions of years of good behavior on the main sequence, burning hydrogen into helium like a nuclear barista. It glows. It hums. Planets ride the warmth like lizards on a heat lamp. Then the core runs out of hydrogen. Party's over. The star puffs up into a red giant, knocking over the furniture and probably swallowing a planet or two because boundaries are a human invention. Helium fuses into carbon and oxygen. The outer layers peel away. Pretty gas shell, misleadingly named a planetary nebula, because astronomers used to label things like they were trying to win Pictionary. What's left is the hot, bare core. A white dwarf, no fusion, just residual heat radiating into space, like a burnt marshmallow still glowing at the edges. Cute. Tragic. Hardcore. Now zoom the clock so far, the minutes disintegrate. The white dwarf cools. The electrons, crammed together by gravity, hold it up with degeneracy pressure. A quantum, no double parking rule so strict, even black holes nod in respect. Temperature hardly matters. Pressure is doing its own thing, the way your cat ignores tax season. The dwarf radiates, dimming. It crystallizes. Yes, literally. Your star turns into a galaxy S, most extra diamond, carbon and oxygen ions settling into a crystal lattice. It releases latent heat as it freezes, like it could not resist one last flex of warmth before joining the cool kids' table permanently. Keep going. The background universe, stretched by expansion, keeps cooling too. The cosmic microwave background, once a fiery toddler at thousands of Kelvin, is now a whisper above absolute zero, a radiator in an abandoned building. The dwarf's temperature chases it downward, like a slow-motion game of tag where both players have arthritis and time is a glacier. Fusion never restarts. Chemistry grinds to a shrug. Motion slows until it's basically a screensaver. Call it a black dwarf. A lightless, cold, Earth-sized crystal of star remains drifting through a darkness so complete, poetry needs a flashlight. This is bleak, you say. Of course. Entropy writes horror better than any novelist. But bleak doesn't mean empty. It's just quiet. The physics is precise. Quantum mechanics props up the corpse. Thermodynamics drains the last glow. General relativity stretches the stage. Even neutrinos had their early cameo, carrying off energy before the curtain cared. It all adds up to a finale without applause. The universe doesn't bow. It gently stops being warm. And if you're wondering why we haven't discovered a black dwarf yet, congratulations, you've noticed time. None exist. The universe is a teenager at 13.8 billion years. Black dwarfs need patience measured with exponents that make your Wi-Fi password look underachieving. We only see the opening act of the cooling. White dwarfs, bright enough to catch, dim enough to pity. They're the embers you stare at long after the campfire, telling yourself there's still heat while your toes disagree. Imagine the sky of that distant era. No Milky Way smear, no Orion flexing, just a field of invisible relics. The brightest thing might be the memory of heat itself, leaking so slowly you'd have to live across eons to call it progress. Gravity still works, sure, but it has the vibe of a security guard patrolling a mall after all the stores closed. Sometimes remnants bump. Mostly, they drift. The loudest sound is a theory doing paperwork behind the counter. You, here, now, are part of the noisy intermission, a brief blaze in a long darkness. Our atoms were minted in furnaces that once bragged about being hot. They will end as decor that doesn't catch the light. There's a poetry in that, if your taste in poetry prefers straight lines and cold conclusions. It's not tragedy. It's itinerary. Why should you care? Because this isn't just astrophysics. It's a perspective adjustment you can feel in your bones. The cosmos doesn't promise drama. It promises consistency. Light surrenders, heat spreads, order loosens. And out of that inevitability, you get galaxies, stars, planets, people, and at least one primate yelling into a camera that the future is a diamond cemetery. Science. Come for the equations. Stay for the emotional weather. Somewhere in that silent future, a black dwarf drifts through a space so empty, it's basically a concept. Its crystal lattice holds the memory of fire. Its surface temperature argues with zero and keeps losing. It doesn't care. Physics doesn't care. Caring was our department. We brought the noise. The universe brought duration. If you want more of this cosmic stand-up with existential lighting, like the video, subscribe, and tell me where you're watching from. I'm curious which planet you're on, or which century. The alarms in the observatory fade. The telescopes settle. The sky keeps not blinking, which raises one small, inconvenient question that refuses to sit down. And the only way to answer it is to pull the star apart and watch what its courage is made of. Because once you see the engine...
The Star Labs fusion alarm trips like a microwave screaming. Your sun is ready. A hologram of a yellow dwarf spins over the floor, humming like an overachieving light bulb. We crank the model's density, and the simulated core coughs out neutrinos like confetti at a physics parade. Fact: a sun-like star stays steady for billions of years by fusing hydrogen into helium in its core. Punchline: it's the universe's longest-running barista shift. 4 protons walk in, 1 helium walks out, and 2 neutrinos ghost the place without paying. Move: that steady fusion, mostly via the proton chain for stars like ours, with a side hustle from the Cieno cycle at slightly higher masses, balances gravity's crush with radiant pressure, so the star doesn't implode like your group project when one guy forgets the deadline. Hydrostatic equilibrium is the star's yoga pose. Gravity pulls in, pressure pushes out. Everything holds still while 10 to the power of 38 fusion events per second foam the cosmic latte. It's the virial theorem in action. Half the gravitational energy funds heat, the other half buys you a stable personality. The photosphere stays at a civilized 5800 K for a sun-like case. The corona throws a million-degree tantrum because magnetism loves drama, and the luminosity barely twitches as long as the core has hydrogen to burn. Moods do change with age. The star brightens slowly over gigayears because helium ash in the core tweaks the mean molecular weight, squeezes the core tighter, and raises the thermostat. Fact: the sun is brighter now than when Earth formed. Punchline: the warranty covers that planets are not. Exhaustion starts quietly. Hydrogen in the very center runs low, while a shell around it still has plenty. The core loses its fusion heater just where it needs it most. Gravity senses weakness like a debt collector with binoculars. The core contracts. Temperature climbs. The star responds by puffing up its outer layers, because stars are that friend who deals with stress by buying big jackets. Red giant time. The radius balloons by tens to hundreds of times. Surface temperature drops into the warm peach range, luminosity spikes, and your inner solar system becomes a sauna with an eviction notice. Fact: the hydrogen-burning region migrates into a shell surrounding an inert helium core. Punchline: it's like discovering the kitchen closed, but room service still delivers bread. While the envelope expands and cools, the core contracts and heats into the 10 to the power of 8K club, where helium earns a shot. For low-mass stars, the helium core is partly degenerate by the time it hits ignition temperature. Degenerate matter doesn't read the room. Pressure there doesn't care about temperature. So when helium fusion turns on, it doesn't gently rise. It cliff dives into a helium flash. Fact: the flash can dump energy equivalent to a sizable fraction of the star's luminosity for a few minutes. Punchline: internal fireworks no one sees, like a private New Year's party thrown in a locked basement. Move: the flash lifts degeneracy in the core and settles it onto the horizontal branch, where helium fuses to carbon and oxygen via the triple alpha process, with a side of alpha captures if conditions get ambitious. Now imagine the envelope. It's shedding mass like a stress tree in autumn. Stellar winds crank up, dust condenses in the outer layers, and radiation pressure on that dust acts like a leaf blower. The star coughs out shells that drift into space, lit by the hot core's ultraviolet tantrum. Somebody in the 18th century thinks it looks planet-shaped in a tiny telescope and names it a planetary nebula, because branding was vibes-based. Fact: the nebula is the star's discarded atmosphere fluorescing in O3, H-alpha, and friends. Punchline: cosmic dry-cleaning bag, keep away from toddlers and civilizations. Move: as mass loss accelerates, the envelope gets too thin to hold onto, gravity loses its grip, and the core stands exposed like a campfire ember in cold air. Enter the compact air, a white dwarf. Mass typically around 0.55 to 0.65 solar masses for a sun-like ancestor. Radius about Earth-sized, call it 1% of the sun's. Density in the neighborhood of 1,000,000 grams per cubic centimeter, which is exactly the density you'd assign if you wanted to end a dinner party. Fact: electron degeneracy pressure supports the dwarf against gravity. Punchline: a quantum seating chart that refuses double bookings, courtesy of the Pauli exclusion principle. Move: temperature of the newly bared core is obscene, hundreds of thousands of Kelvin, but it isn't doing fusion anymore. It's just hot because gravity squeezed it and can't take a joke. There's a ceiling to this trick, the Chandrasekhar limit, 1.4 solar masses for a carbon-oxygen composition with a non-rotating, non-magnetized disclaimer that theorists love. Go above it and electrons get bullied into relativistic speeds, pressure stops scaling helpfully, and the dwarf cannot cope. Below it, the dwarf survives as a degenerate ember with excellent posture. Fact: the surface gravity is 10 carat 5 times Earth's. Punchline: trip here and your face meets the ground at Mach nope. Move: with fusion done, the only power source is cooling, photons walking off with the last heat, sometimes neutrinos stealing energy early when the core is still too hot to shut up. If the progenitor star was a bit heftier, say 8, 10 solar masses and flirting with neon, core densities could push toward oxygen, neon, magnesium compositions. That changes the backstage chemistry and the possible detours near electron capture supernova territory, but the lane we're in keeps it carbon, oxygen. The dwarf's atmosphere stratifies under crushing gravity. Lightest elements float to the top. Hydrogen layers form if any survive the mass loss. Helium if hydrogen got singed. Metals settle because sedimentation loves high gravity the way gossip loves group chats. Spectroscopically, we call them Da, hydrogen atmospheres, or Db, helium, which sounds like a club list and functions like one. Inside, pressure is mostly about electron momentum, not temperature. You can cool a white dwarf by orders of magnitude, and its size barely flinches. That's a weird, delightful fact you can bring to any party that already went weird. The heat capacity lives in the ions more than the electrons. The electrons are too busy being quantum furniture. Early on, neutrino emission dominates, cooling like a teenager dominating the AUX chord. Fast, efficient, and just a bit rude. Later, photon radiation from the surface takes over, slow and steady, like classical music after midnight. The dwarf glows bravely, radiating its stolen gravitational energy back into space molecule by molecule. Well, photon by photon, but allow the drama. Parallax missions like Gaia map white dwarfs by the hundreds of thousands, plot them on color, magnitude diagrams, and trace crisp cooling sequences that look like gravity's handwriting. Astroseismology catches starquakes, non-radial G-modes ringing the dwarf, which let us taste the internal layering the way you tap a watermelon and pretend you hear anything useful. The spectrum broadens lines via Stark effects because the electric fields in that atmosphere are unreasonably large, and you can practically hear the electrons filing HR complaints. Meanwhile, the dead star keeps losing heat, and the ion soup inside starts thinking about order. Coulomb coupling parameter gamma climbs as temperature falls. When gamma breaches 172 for a one-component plasma, the ions decide chaos was a phase and lock into a crystal lattice. Latent heat leaks out during the phase transition, stalling the cooling clock, like the dwarf found a hidden battery under the couch cushions. The phase diagram isn't just a napkin sketch. Impurities and phase separation can shove oxygen inward and carbon outward, altering the cooling rate and the chemical zoning, which is exactly the sort of petty redistribution a frozen remnant would hold onto for eons. Back in the lab, the hologram white dwarf dims a notch. The neutrino channel drops to a mutter. The radiative output is still cocky, but the slope of its decline is a confession written in infrared. The core density tightens toward 10^6G/cm superscript 3, electrons elbow to elbow, ions vibrating like a choir with stage fright. The thermal reservoir is shrinking. The lattice is forming in clumps. Every photon that escapes drags the temperature meter down a tick. Pressure doesn't blink. Gravity presses a palm to the door, patient as ever. Somewhere between the next quiver of a G-mode and the next faint packet of light, the star's embers lean closer to solid, and the thermometer starts spelling out a question the atmosphere can't answer yet. We kill the lab lights and wheel the corpse under a spectrograph like CSI, astronomy. Fact: the remnant on the slab is Earth-sized with a mass comparable to the Sun punchline. It's the cosmic version of fitting a piano into a backpack and pretending that's fine. Move. Shrinking a star to a planet's radius boosts surface gravity to 10^5G. So a tossed pebble hits like it's angry at you personally, and every atom knows its place because gravity wrote the seating chart in all caps. Crack the file on composition. Fact: most of these embers are carbon, oxygen in the core, layered like a very judgmental onion under either a helium or hydrogen atmosphere. Punchline: it's a wedding cake where the frosting decides the menu because spectra only taste the top millimeter. Move. Heavy elements sink within minutes to days under the crushing gravity. Metals plummet, hydrogen floats. So if you see calcium lines, the dwarf just ate a rock and hasn't finished burping. Now the support system. Fact: pressure inside isn't thermal, it's quantum, electron degeneracy. Punchline: the Pauli exclusion principle is the bouncer who refuses to let two electrons share the same seat, even when gravity flashes a VIP badge. Move, pack electrons tighter, their momenta rise, pressure goes up without asking temperature's opinion. That's why the dwarf stays puffed even as it cools. Temperature is not invited to the structural meeting. Run the mass radius curve. Fact: add mass, the radius shrinks. Take mass away, the radius grows. Punchline: it's an anti-Instagram filter. More gains, smaller look. Move. Near the Chandrasekhar cliff, 1.4 solar masses for a carbon-oxygen mix. Electrons become relativistic divas, pressure gains stop keeping pace, and the curve nosedives. Our ember sits safely below that, content to be dense rather than dramatic. Take its temperature. Fact: fresh from the furnace, a white dwarf can exceed 100,000 K, radiating like a guilty conscience in the extreme UV. Punchline: it's not hot because it's working. It's hot because gravity squeezed it the way deadlines squeeze sleep. Move: the only energy source is a finite thermal bank account deposited during formation. Every photon that leaves is a transaction, and unlike your credit card, there is no generous overdraft. Early cooling is a neutrino heist. Fact: at high interior temperatures, 10^7, 10^8K. Plasmon decay and pair processes spit neutrinos that ghost through space carrying energy you'll never see. Punchline: it's like losing heat to thieves who walk through walls and refuse to show up in court. Move: as the core cools below the neutrino-screaming regime, surface photons take over the bill, and the luminosity decline loosens its tie and gets into a long commute. Conductive opacity runs the thermostat. Fact: electrons, degenerate and mobile, conduct heat ridiculously well, flattening temperature gradients like a cosmic iron. Punchline: your ember is a single, sulking radiator wrapped in a thin blanket. Move: that blanket matters. A hydrogen veneer as skinny as 10 to the power of -4 solar masses insulates better than a helium-1. Swap the atmosphere, and you alter the cooling clock by gigayears, which is petty in human terms and loud in dwarf terms. Peek at the equation of state. Fact: for non-relativistic degeneracy, P is proportional to rho caret 5/3. Flirt with relativistic speeds and it shifts toward rho caret 4/3. Punchline: it's the only time a fraction ruins your life on a cosmic scale. Move: most interior zones live in the comfy non-relativistic regime, but the core plays near the border, which matters for the mass ceiling and how sharply the star answers to compression. We mic the star for quakes. Fact: non-radial G-mode pulsations rattle the dwarf, timing beats sensitive to internal layering, composition, and crystallization. Punchline: seismology for a dead star is like reading a diary through the thumps on a wall. Move: match observed periods to models and you get core oxygen fractions, envelope thicknesses, and where the solid phase has started to lock in, spy gear for astrophysicists with patience issues. Gravity tries one more flex at the surface. Fact: spectral lines are shifted by gravitational redshift. Photons climb out and lose energy. Punchline: your light leaves with a limp. Move: measure the shift, pair it with parallax distance and flux, and you triangulate mass without opening the star, which is considerate for lab safety. Magnetism barges in. Fact: some dwarfs carry megagauss to gigagauss fields, distorting spectral lines with Zeeman splitting and turning atmospheres into plasma ballet recitals. Punchline: it's a fridge magnet that can reconfigure your electrons and your confidence. Move: fields influence conductivity, envelope convection, accretion streams from binary partners, and even how heat sneaks out, so every Gauss is a plot twist. Let the ions talk. Fact: inside, carbon and oxygen nuclei form a strongly coupled plasma. As temperature falls, the Coulomb coupling parameter gamma climbs past the melt threshold, and the ions crystallize into a lattice. Punchline: the star becomes the galaxy's rudest diamond, pretty, cold, and not into small talk. Move: the phase transition releases latent heat, flattening the cooling curve. Phase separation tends to sink oxygen and float carbon, wringing out extra energy as gravity does bookkeeping on the rearrangement. Mestel's law gives the early script. Fact: to first order, luminosity scales like T-5/7 for a cooling dwarf under simple assumptions. Punchline: a back of the envelope you can trust until the envelope gets soggy. Move: real life adds neutrino losses up front, crystallization bumps in the middle, and to buy cooling down low when the lattice heat capacity scales like T/theta_D⁻3, choking the reservoir to a whisper. Atmospheres still misbehave. Fact: at low effective temperatures, H2 formation and collision-induced absorption shift opacity into the infrared, making very cool hydrogen atmospheres look deceptively blue in optical colors. Punchline: your coldest dwarfs cosplay as not-so-cold ones, and photometric catalogs fall for it like it's Tinder. Move: modeling those opacities correctly decides whether you age a dwarf by 1 gig-a-year or by 3, which changes the script for entire stellar populations. Binary life leaves fingerprints. Fact: some dwarfs steal a trickle of gas from companions, pollute their atmospheres with metals, or merge into Super Chandrasekhar mischief. Punchline: even retired stars find drama in the group chat. Move: accretion changes line profiles, heats patches, and occasionally lights up novae. Mergers sculpt masses and spins that you only catch if your model remembers to ask about X's. Observables stack into a dossier. Fact: Gaia nails distances and motions. HSD and ground-based surveys pin colors and temperatures. Spectrographs parse atmospheres, and pulsation timing taps the core. Punchline: it's a full-body scan for something that technically no longer has a metabolism. Move: cross-match these to set the dwarf's age, mass, composition, envelope thickness, magnetic personality, and how far it's marched along the cooling track toward the point where light budgets start needing exponents just to move a decimal. We dim the spectrograph. The model's luminosity ticks down another microscopic notch. Photon by photon, the thermal balance sheet trims itself, with neutrinos mostly off the payroll and conduction running a tight ship. The lattice fraction creeps higher, the Dubai temperature peaks over the ridge, and the atmosphere's opacity keeps renegotiating how fast the heat can slip out past the last stubborn electrons. The ember isn't dead, it's disciplined. The thermometer numbers keep sliding toward a background that also refuses to sit still, and that sliding edge hints at a slower gear we haven't spun up yet, the one where the cosmos stops providing a warm sink, and the dwarf has to chase a target that won't hold still. We set the dwarf on a cosmic treadmill and watch the wattage bleed like a battery left in a flashlight for 3 winters. Fact: once neutrino cooling quiets down, photon radiation out of the surface carries the energy loss. Punchline: it's a space heater trying to warm an empty warehouse, and the warehouse keeps getting bigger. Move: the luminosity slides, the spectrum drifts red, and the photosphere's molecules start forming like party guests who suddenly remembered they're introverts. Convective coupling sneaks in. Fact: as the outer layers cool, the envelope becomes convective and hooks the surface straight to the interior's deeper heat. Punchline: it's like ripping off the insulation because you're sure the draft is fine. Move: the coupling temporarily increases the cooling rate. Heat reaches the surface faster. So the dwarf drops a gear on its way down the HR diagram and coasts with less patience. Opacity rewrites the look. Fact: at low temperatures, hydrogen turns into H2 and collision-induced absorption shoves the outgoing radiation toward the infrared. Punchline: the star's fashion choice is invisible in your telescope, influential in the microwave. Move: helium atmospheres misbehave differently. He and He-H2 collisions make their own opacity zoo. So 2 dwarfs with the same core can age at slightly different social speeds if they wear different coats. The lattice gets serious. Fact: carbon-oxygen ions freeze into a crystal, releasing latent heat that briefly interrupts the slide like a stubborn elevator stopping at a surprise floor. Punchline: your dead star saves warmth the way a miser saves coupons. Move: phase separation during freezing sorts ions by charge and mass. Oxygen tends to sink, carbon tends to float, which lets gravity cash in more energy just from tidying the pantry. Metallicity left souvenirs. Fact: a few percent of the core's nuclei are neon-22, born from cyano ashes in the progenitor. With 2 extra neutrons, superscript 2, known as heavier per charge and slowly sediments inward. Punchline: the dwarf invents glacial geology in a place with no weather. Move: that sedimentation drips gravitational energy into the budget for gigayears, nudging the cooling clock like a passive-aggressive wall clock that runs 5 minutes late on purpose. Thermal physics turns minimalist. Fact: once most ions are locked in the lattice and the temperature sinks below the Dubai threshold, the ionic heat capacity drops is proportional to T/theta_d3. Punchline: your heat reservoir shrinks into a stingy accountant who rounds down everything. Move: cooling gets sluggish, each Kelvin costs more time. So the curve flattens like a marathoner who forgot snacks at kilometer 30. Gravitational contraction is done. Fact: degeneracy pressure decouples structure from temperature, so radius barely changes as it cools. Punchline: it's the only corpse that keeps its figure forever because quantum mechanics says so. Move: without contraction energy, the dwarf's only income is whatever heat remains, plus those petty bonuses from sedimentation and phase separation that physics leaves on the nightstand. Numbers try to scare you. Fact: a typical 0.6 solar mass dwarf slides from 20,000 K to a few thousand K in billions of years, then crawls through the last thousands of Kelvin for much, much longer. Punchline: fast at first, painfully slow later, like New Year's resolutions. Move: once effective temperatures fall into the few hundred Kelvin club, the emitted spectrum lives in the mid-IR and beyond, where even ambitious telescopes squint and shrug. Background sets the thermostat. Fact: the cosmic microwave background bathes everything at 2.725 K today and cools with expansion. T_SMB is proportional to A superscript 1. Punchline: the universe is that roommate who keeps turning down the thermostat and swears it's cozy. Move: the dwarf radiates into this bath. As both cool, its temperature asymptotically chases the ever lower CMB like a cat stalking a laser pointer that won't stop moving. Equilibrium is a moving target. Fact: the dwarf's radiative power is proportional to sigma T_FF, wants to approach the background power from absorbed CMB photons. The balance point slides as the CMB redshifts. Punchline: you can meet your goal if your goal keeps running away. Move: the dwarf never quite stops radiating. There's always a tiny differential to bleed. So black dwarf is not a switch, it's a vibe measured in exponents. Surface chemistry keeps scheming. Fact: at a few hundred Kelvin, H2O, CH4, NH3 would be happy molecules if any existed. In a pure H/He veneer, the main players are still H2 and He, but dust-like condensates may form under exotic conditions. Punchline: the atmosphere wants to cosplay as a rogue planet, but the wardrobe budget is quantum. Move: any condensates tweak opacity again, sliding flux deeper into wavelengths your detector calls philosophical. Magnetic fields refuse to retire. Fact: megagauss fields funnel heat and possibly suppress convection, patching the photosphere with temperature differences minute by minute across geological eternities. Punchline: it's a dead star wearing a permanent beanie and insisting that's its thing. Move: spotty envelopes introduce small, persistent asymmetries that modulate cooling locally. A detail only relevant if you're the kind of civilization that times flickers across trillion-year calendars. External energy sources dry up. Fact: interstellar accretion at these late epochs is meager. Gas is scarce, galaxies are anemic, and expansion dilutes ambition. Punchline: even freeloading gets hard when the universe is out of snacks. Move: occasional dust grains will still splatter and briefly light microscopic pixels, but they count the way single snowflakes count toward your heating bill. Dynamical time stretches. Fact: encounters with other remnants continue, but velocities are high, densities low, and capture cross-sections tiny. Punchline: it's speed dating where no one brings a pen. Move: most dwarfs drift solo, cooling in monastic silence, with gravity as their quiet abbot and phonons as the chant that never learns a new verse. Detectability collapses. Fact: below a few hundred Kelvin, blackbody peaks sit at tens of microns to millimeters, and luminosities fall orders of magnitude beneath planetary glow. Punchline: trying to see one is like trying to photograph darkness with darker. Move: even if you stood on a neighboring remnant, you'd need instruments that make absurd sensitivity look like a budget line item, and the budget left the galaxy epochs ago. The label arrives by stealth. Fact: black dwarf is the limiting state of a white dwarf after it cools to the ambient background with negligible thermal emission. Punchline: it's not actually black, it's so dim your descendants would argue about whether it's on. Move: the object becomes a cold, crystalline planet-sized relic, mass intact, pressure unchanged, structure frozen, photons trickling like the last drips from a faucet you already turned off. Inside the crystal, defects linger. Fact: Vacancies, dislocations, and impurity clusters carry microscopic energy and can migrate via quantum tunneling even at vanishing temperatures. Punchline: the corpse fidgets in its sleep and calls it a hobby. Move: every small rearrangement dribbles a little heat, so the ledger never closes to absolute zero. It just writes smaller and smaller numbers with a duller pencil. We dim the hologram until the lab is lit by the screen's timestamp alone. The model's effective temperature slips under triple digits, the spectrum slumps into wavelengths humans call radio silence, and the lattice fraction is basically a mathematical shrug with a 1.000 after it. The background keeps cooling on schedule set by geometry, not mercy. The dwarf keeps matching steps, patient to the point of parity, while the last non-thermal tricks, sedimentation, defects, weak convection, spend themselves like coins found under old floorboards. Somewhere beyond the room's blue glow, the calculation bumps into a different question, the kind that doesn't check with the thermostat before it knocks. And the way to answer it is to ask what happens when the quiet crystal isn't as perfectly quiet as we pretended. We drag a wall clock into the lab, set it next to the model dwarf, and it faints from embarrassment. Fact: no black dwarfs exist yet because the universe is 1.38 times 10 superscript 1 years old. Punchline: cosmology is a teenager sneaking into an adults-only movie. Move: white dwarfs need orders more time to cool into invisibility. Numbers that make your calendar look like a sticky note with snack written on it. Start with the easy cruelty. Fact: a typical 0.6 solar mass white dwarf might take 10 superscript 1, 10 superscript 1 years to coast into true darkness where its effective temperature hugs the background. Punchline: that's 100 trillion to a quadrillion years, or roughly how long it takes a group chat to decide where to eat. Move: those are not precision times, they're hazard lights blinking on the highway of forever, because the rate depends on composition, envelope thickness, magnetic personality, and whether physics throws in petty cash like superscript 2 sedimentation. The background keeps cheating. Fact: the cosmic microwave background temperature falls as T_B is proportional to A superscript 1, whereas the scale factor of the expanding universe. Punchline: the universe is stretching its sweater until it stops counting as clothing. Move: as the CMB cools, the dwarf's target temperature slides away. You're not approaching equilibrium so much as shadowboxing a ghost with ice cubes. Entropy insists on monotony. Fact: the only legal direction for net heat flow is from warmer to cooler, and the universe is the biggest refrigerator anyone could afford. Punchline: thermodynamics is the party host who turns on fluorescent lights at 9 p.m. Move: the dwarf radiates, the background chills, and the gap narrows on a schedule ruled by geometry, not audience applause. The numbers are slow enough to make continental drift look impulsive. Now stretch your intuition until it snaps. Fact: crystallization can unfold over billions to tens of billions of years, depending on the mass and composition, but that's just the mid-credits scene. Punchline: the post-credits teaser is the next 10 superscript 1 superscript 3 years of still cooling thanks. Move: once the lattice locks and the Debye heat capacity starts scaling like T/theta_d superscript 3, the thermal reservoir becomes miserly. Each Kelvin costs decades of exponents, and the curve turns into a crawl that would make tectonic plates roll their eyes. The CMB cooling timescale piles on. Fact: if you want a nearly microkelvin universe, you're eyeballing 10 superscript 1 superscript 2, 10 superscript 1 years and beyond, depending on what cosmology you spoon in. Punchline: we started with long and ordered longer, and the chef brought out conceptual soup. Move: by the time the background is cold enough that a black dwarf's last photons are basically a rumor, galaxies have had more mergers than a telecom provider, and star formation is the kind of story old halos tell to look interesting. Galactic clocks drag their heels. Fact: dynamical times in a Milky Way type halo are 10 years, but evaporation, mass loss, and encounters over trillions of years dissolve bound structures into a diaspora of remnants. Punchline: your local group becomes a local rumor. Move: the dwarf's cooling is agnostic to address, but the evaporation of its neighborhood ensures the only thing knocking on its door is passing gravity with no business card. Someone asks about proton decay because every crowd has a philosopher. Fact: many grand unified theories predict proton half-lives 10 superscript 3, 10 superscript 3 years. Experiments have only set lower bounds, not confirmations. Punchline: the universe might uninstall baryons on a free trial you never agreed to. Move: if protons decay, black dwarfs become weight loss influencers over epochs long enough to make eternity check its watch. Mass dribbles away as positrons and neutrinos leak out like polite thieves. But maybe protons are stubborn. Fact: if the proton is stable, a black dwarf holds its mass until something external bumps it. Tidal encounters, capture, or eventual dance with a black hole. Punchline: immortality, but make it boring. Move: the remnant persists, crystal core unbothered, a monument to quantum resistance and excellent posture, while the universe outside trends toward the thermal dress code of bring a coat. Put these clocks on the same table. Fact: white dwarf to black dwarf, 10 superscript 1, 10 superscript 1 year. Plausible CMB microkelvin, 10 superscript 1 superscript 2, 10 superscript 1 year. Hypothetical proton decay drama, greater than or equal to 10 superscript 3 year. Black hole evaporation for stellar mass holes, 10 year, and supermassive ones can lounge past 10 superscript 1 year. Punchline: the cosmos measures patience in units that bully calculators into scientific notation. Move: a black dwarf's dimming finishes its interesting work long before black holes finish theirs, leaving the stage light set to hospice. Fine-grained delays sneak in. Fact: trace nuclides like superscript 2 superscript 2, and settling inward and phase separation during crystallization add gigayears to the schedule by paying out gravitational pennies with the enthusiasm of a broken parking meter. Punchline: the dwarf gamifies its own cooling with microtransactions. Move: each bonus is tiny but honest, and the pile stretches the path like chewing gum pulled between two galaxies. Atmospheres pace the clock too. Fact: a hydrogen skin traps heat better than helium. Collision-induced absorption flips the radiative efficiency card. Even a magnetic field can tweak convection enough to buy or sell a % of time here and there. Punchline: the difference between only 80 trillion years and 120 trillion years is the cosmic version of arguing over which paint dries faster. Move: population studies fold those details into cooling tracks that age star clusters, calibrate galactic archaeology, and whisper about how long until the embers leave the visible party entirely. Even language trips. Fact: we say approach absolute zero, knowing quantum fluctuations, defect migration, and the moving CMB target conspire to keep the thermometer from reading a perfect zero. Punchline: absolute zero is like inbox zero, philosophically clean, experimentally haunted. Move: what matters is not hitting zero but starving emission until you couldn't detect it with a detector made of hubris and miracles. And because time is rude, our last reference point shrugs off comfort. Fact: if dark energy sticks with a cosmological constant, expansion accelerates, horizons form, distant remnants redshift out of causal reach. Local island universes become a hobby project. Punchline: the universe installs privacy settings and forgets the password. Move: the black dwarf's environment simplifies to loneliness with excellent geometry. Its timeline answers to one master equation with no coffee breaks. We glance at the faint curve on the monitor. It's the slope of a life draining on laboratory terms that stopped being human 3 paragraphs ago. The dwarf's temperature falls, the background slides, the gap narrows with the frictionless stubbornness of math, doing exactly what it promised. Clocks in the room tick like woodpeckers in a forest that's already turned to stone, and the only honest thing left to do is ask what happens when most of matter has taken this vow of silence, and the sky's brightness budget pays out in coins you can't see, which is awkward, because something out there still has a way of making itself heard without asking light for permission. The sky does the light equivalent of Irish goodbye. Fact: star formation runs out of raw gas as galaxies blow it out, lock it up in long-lived stars, or heat it beyond the let's settle down phase. Punchline: the cosmos tried binge building and discovered supply chains. Move: with molecular clouds shredded by feedback and mergers, the Kennicott, Schmidt Law turns into a nostalgia playlist, and birth rates slide from sparkling to don't call us. Gravitational housekeeping keeps happening. Fact: orbits in galaxy halos puff up under dynamical heating, ram pressure stripping lifts gas from satellites, and tidal fields fillet dwarf galaxies into streams. Punchline: the Milky Way becomes a charcuterie board. Move: these processes starve star formation while moving mass into long, cold corridors of nothing, where a gas atom can spend 1 billion years composing a haiku and never be read. The demographic shift is not subtle. Fact: over cosmic ages, luminous populations retire into remnants, white dwarfs, neutron stars, and black holes, plus a crowd of brown dwarfs, rogue planets, and debris that never earned a birth certificate. Punchline: daycare closes. The nursing home takes the lease. Move: the main sequence census thins. Remnants and substellar objects become the default baryonic furniture, and the stellar IMF cashes out into an HR chart labeled degenerate. Galaxies still collide until they don't. Fact: in a lambda-CDM universe, local bound structures keep merging while cosmic acceleration drives distant ones outside the event horizon. Punchline: it's networking in a room that's locking its doors one by one. Move: the local group coalesces into a single red puffy remnant, pick your portmanteau, then spends trillions of years digesting itself, burping out tidal tales too faint to matter and too pretty to see. Light loses the argument with entropy. Fact: with no fresh fusion, bolometric luminosities of galaxies fall into the basement. Late-time energy output comes from cooling embers, radioactive leftovers, and the occasional accretion scuffle. Punchline: the night sky is vibes only. Move: integrated backgrounds that once sang in UV/optical now hum dull in the far IR and microwave, and even that hum is a fading memory a patient spectrometer would write a sonnet about if it could afford verbs. Remnants start calling the shots gravitationally. Fact: white dwarfs on their way to black, neutron stars, and black holes dominate the baryonic mass budget of long-lived systems. Punchline: the universe becomes a retirement community run by the Residents Association. Move: velocity dispersions answer to dark matter and dead matter. Disks thicken, bars weaken. Spiral patterns fade into an archaeology exhibit you navigate with a flashlight and a grant proposal. Encounters continue, but they're stingy. Fact: stellar remnants still pass, scatter, and sometimes exchange binding energy, yet cross-sections for interesting captures shrink as gas disappears and relaxation times go prison sentence long. Punchline: it's speed dating with non-disclosure agreements. Move: most remnants drift solitary, microlensing now and then like a ghost tapping a lens. If you're counting events, bring snacks labeled eon-sized. Accretion wears a hair shirt. Fact: with dense gas gone, accretion onto compact objects slumps to Bondi sipping from a desert, punctuated by tiny meals from disrupted asteroids or skinned comets. Punchline: black holes become intermittent fasters. White dwarfs collect crumbs and call it cuisine. Move: the fireworks of AGN and X-ray binaries de-escalate to pilot lights, and the loudest flare might be a pebble making a spectral line cry. Cosmic rays still exist, but they're not hiring. Fact: without young supernovae pumping the accelerator, the highest energy end of the spectrum empties out. Low-energy backgrounds hang on courtesy of old shocks and decaying fields. Punchline: the universe keeps the radio on, but every station plays elevator. Move: magnetic turbulence damps, diffusion lengths inflate. Charged particles wander longer through quieter fields, turning cosmic ray astronomy into cosmic shrug statistics. Dark matter remains the quiet landlord. Fact: halos keep their grip as baryons cool away their ambition. The potential wells are set by non-luminous mass with terrific boundaries and terrible interior decoration. Punchline: the Homeowners Association is invisible and always right. Move: phase mix streams loop through like whispers. Resonances decay. Subhalos persist as lumps that nothing luminous bothers to outline anymore. Thermal physics does slow jazz. Fact: the last warm things, white dwarfs, continue bleeding photons while their cores crystallize deeper and their envelopes negotiate opacity like lawyers billing by the page. Punchline: heat becomes artisanal, small batch, ethically sourced. Move: As effective temperatures dip below room temperature, emission peaks ooze into wavelengths more at home in cryogenic dreams than telescopes built by optimists with budgets. Planetary systems devolve into pinball. Fact: as host stars shed mass on the way to white dwarfs, orbits expand. Later, long-term N-body chaos kicks comets inward or out. Planets scatter, moons desert. Punchline: Kepler becomes Jerry Springer. Move: a fraction of that chaos pollutes dwarf atmospheres with metals. The rest builds cold belts of rubble circling relics that don't take family photos. Neutron stars keep their weird. Fact: magnetic fields decay, spins slow, pair cascades quit. Millisecond pulsars dim into retirees timing their nothing with ridiculous precision. Punchline: cosmic lighthouses turn into porch bulbs with opinions. Move: a few close binaries still merge after long gravitational wave courtships. When they do, they spit out a whispered chirp across an ocean of quiet, and any surviving detector gets a headline without pictures. Black holes remain the drama queens by default. Fact: even on starvation diets, they dominate the compact object mass function's high end. Dynamical friction herds them to centers, where they loiter like bouncers waiting for a party that forgot to happen. Punchline: event horizons aren't picky, they're patient. Move: occasional captures, rogue dwarfs, exhausted stars, unlucky rocks, convert rest mass into faint heat efficiently, but rarely enough to count, like meteors in a city you moved out of. The radiation field goes cashless. Fact: with starlight thin, background energy density is CMB lead, then line and dust leftovers, then whatever leaky processes refuse to sign their resignation letters. Punchline: the sky's exposure triangle is ISO, bless your heart. Move: your hypothetical eyeball adapts, fails, and invents a new sense organ tuned to whispers of gravity and the sigh of phonons, which is great, because photons are filing for quiet quitting. Entropy keeps climbing, but complexity retreats. Fact: free energy sources shrink. Systems slide toward microcanonical boredom. Low-entropy gradients that once paid for chemistry become rare luxury goods. Punchline: civilization is a thermodynamic side project with funding issues. Move: any structures still doing work rely on salvage, tidal heat, radioactive crumbs, stored gradients in degenerate matter, while the big picture amortizes into uniformity with excellent accounting. On the ledger's baryonic side, the majority brand becomes cold, degenerate, dim. Fact: what used to be the galaxy's main power plant is now a crystal sphere radiating like a lost ice cube. Punchline: the universe replaced its light bulbs with decorative stones. Move: stack enough of them and you own the mass budget. Look for them and you find an empty stage with scuffed floors and a locked lighting booth. We let the model run with the room silent. Velocities drift, potentials settle. Catalogs shrink to names only gravity remembers. The brightness book closes to a line item labeled residual, and the long arithmetic of heat drips on while mergers, captures, and stray collisions shuffle remnant chips across a table no one is watching, which would be a tidy place to stop if the embers didn't carry a trick that cares nothing for starlight or schedules and prefers to work inside a crystal where distance is short, temperatures are stingy, and quantum tunneling keeps a spare key under the doormat. We zoom into the crystal like thieves inspecting a safe. Fact: at ridiculous densities, nuclei sit so close their wave functions gossip through the lattice. Punchline: social distancing ends when gravity owns the venue. Move: temperature doesn't help them meet, quantum zero-point jiggle does. So fusion becomes a tunneling problem with no RSVP, just improbable handshakes across a barrier that looks offended anyone tried. Name the mischief. Fact: pycnonuclear fusion is density-driven burning where carbon or oxygen nuclei tunnel and merge at temperatures that would make a glacier brag. Punchline: it's candlelight dinner at 10 to the power of 6G/cm superscript 3 with the thermostat unplugged. Move: in a carbon-oxygen dwarf, the rates hide behind exponentials, so mean you need scientific notation just to spell maybe. Still, the lattice vibrates, the nuclei hop, and probability leaks like a faucet you swore you fixed. The math is petty and decisive. Fact: the fusion rate per pair scales like exp minus b slash square root rho underscore ff, once you fold in screening and 0-point motion. Punchline: Raise the density, lower the impossibility tax. Move. Most of the star never reaches a party where this matters, but central pockets do. And in those pockets carbon can fuse to neon. Magnesium sets while oxygen eyes silicon pathways. All in whispers so faint even neutrinos would ask it to speak up. Energy accounting refuses to be casual. Fact. Each fusion event drops a few MeV into the local cell. In a perfect conductor with degenerate electrons, heat moves fast, but not infinitely fast. Punchline. You can start a rumor faster than you can stop it. Move. If local heating outruns conduction and neutrino losses, a micro-runaway can snowball, and you've built a match in a room full of very patient kindling that forgot it was wood. Cue the absurd clock. Fact. Some models push first serious pycnonuclear ignition for carbon cores to timescales like 10^1100 years if proton decay never shows up and the universe keeps its expansion habit. Punchline. That's not a number, that's performance art. Move. The point isn't precision, it's posture. Quantum tunneling never says never. It just makes later so far away your metaphors quit. The lattice helps and hinders. Fact. Strong Coulomb screening lowers effective barriers, but crystallization pins ions in place, reducing thermal excursions that would help tunneling. Punchline. The star installs a child lock and then forgets the code. Move impurity pockets, neon 22 magnesium, oddball isotopes, distort local spacing and can either tilt the odds or sop up heat. Microphysics makes its money in the decimals. We flirt with catastrophe responsibly. Fact. If a critical mass of carbon lights under degenerate conditions, pressure doesn't expand with temperature, so burning can flash hot without a stabilizing puff. Punchline. It's lighting a stove in a submarine and hoping the water notices. Move. On white dwarfs, that's a type Ia story. On black dwarfs, rates are glacial and the fuse is measured in universes, yet the mechanism rhymes. Degeneracy makes temperature a reckless driver. Now the heresy. What if baryons are temporary? Fact. Many grand unified theories want protons to decay with half-lives beyond 10^34, 10^36 years, with favored channels like Pe plus pi whispering mass into radiation. Punchline. Matter might have a warranty with unread fine print. Move. If decay is real, black dwarfs don't wait for tunneling drama. They just lose nucleons the slow way, shedding mass like an eternal fad diet, until the lattice turns to a rumor held together by accounting. Decay rewrites the heat ledger. Fact. Each decay liberates GV that ends up as gamma rays and lighter particles cascading into heat, then photons, then empty space. Punchline. The corpse runs a space heater powered by its own atoms signing resignation letters. Move. The energy trickle is microscopic per second, but relentless per epoch. Structure loosens, gravity relaxes. Degeneracy still holds while the census of protons drops, and every step pulls the star down the mass. Radius relation like a reluctant suitcase on stairs. Cross a limit, pay a fee. Fact. As mass falls, the dwarf expands slightly. As composition shuffles toward leptons and photons, binding changes. Near the low-mass fringe, the object drifts toward a not-quite planet of ghostly leftovers. Punchline. You end up with the world's saddest puffball. Move. In the very long run, enough decays and beta rearrangements dissolve the lattice into a bath of leptons and radiation that forgets it was ever crystal. And forgetting keeps going because time is rude. Suppose protons refuse. Fact. Stability would leave the dwarf intact until external gravity steals it, most likely into a black hole's diet plan. Punchline. Immortality with a chance of being dinner. Move. Central black holes in future island universes will still sit like drains in a dry sink. A passing black dwarf's pericenter too close, and tides shred it into a glowing trickle that ends across an event horizon, which is neat for thermodynamics and rude to nostalgia. Dark matter peaks around the door. Fact. If weakly interacting particles exist and scatter off nuclei, they can be gravitationally captured, sink, and annihilate in the core. Punchline. Airbnb inside a dead star with complementary self-destruction. Move. Capture rates scale with ambient density, which the late universe doesn't lavish on neighborhoods. Annihilation heating then is a footnote unless new physics hands out coupons, and physics rarely does. Magnetic subplots won't sit down. Fact: Megagauss fields quantize electron motion into Landau levels, tweaking screening lengths and transport in ways that turn small into notice me. Punchline: the star got a tattoo it won't stop mentioning. Move: even a few percent change to conductivity or screening shifts ignition thresholds, so the map of where tunneling wins becomes a weather report no one can forecast without more decimals than anyone wants to type. Gravity waves take a bow. Fact: in rare long-tail encounters, two relics can spiral together by emitting gravitational radiation, coalescing after time spans that make stalactites look impulsive. Punchline: romance by frictionless mail. Move: mergers of cold dwarfs can reheat interiors, melt crystals, and, if the total mass noses near the Chandrasekhar cliff, reignite the old thermonuclear script in a cosmos that forgot what light was supposed to feel like, leaving behind an aftertaste you'd only catch if you timed the dark with unreasonable faith. We return to the core and listen. Fact: even at microkelvin effective temperatures, the zero-point motion never cancels, defects never count to zero, and tunneling never truly says no. Punchline: the quiet has loopholes. Move: every loophole is a timetable written in exponent stacks, and every timetable is an energy pathway that leaks or lights depending on whether probability stumbles into enough neighbors before conduction, neutrinos, or decay smother the mood. Somewhere between protons resign and carbon elbows through the barrier, there's a ledger that must balance. Fact: energy in any form still has to wander downhill into colder space. Entropy still asks for more microstates. No process gets a hall pass. Punchline: the last accountant in the universe is the second law wearing a black turtleneck. Move: a black dwarf can ignite by tunneling or evaporate by decay, can fall into a horizon or be nibbled by defects, but every route pays the same tax in heat leaked to emptier backgrounds that refuse to stop being emptier. The model waits on our screen, crystalline and argumentative in silence. The fusion channel is a decimal that looks like a dare. The decay switch is a coin the cosmos hasn't flipped where we can see. Capture cross-sections are napkin math placed under the leg of a wobbly table. Heat still has to leave, order still drifts, and the crystal still keeps score with phonons so faint you'd miss them unless you were patient enough to watch numbers move like shadows, which is tempting, because the next whisper from the lattice isn't a flare, it's a negotiation with the last gradients left standing. We put the crystal on audit. Fact: the only income left is internal heat. The only expense that matters is radiation into a colder bath. Punchline: the business model is warmth leaves. Move: the second law signs every invoice, and the signature is entropy production, del S/del T greater than or equal to 0, with no appeal court except mathematics wearing sensible shoes. Start with the ledger that actually counts. Fact: the relevant currency isn't energy alone. It's free energy. Helmholtz F equals U minus TS, because only delta F pays for work. Punchline: calories brag, free energy pays rent. Move: as the dwarf cools, T drops and S creeps up, and every whisper of structured order inside buys its way out by bleeding delta F into photons your detector would call rumor. The radiator is honest to a fault. Fact: power out is sigma A epsilon T underscore FF, so long as the surface acts like a gray body and the photosphere is optically thick. Punchline: Stefan and Boltzmann invented the universe's dimmer switch. Move: emissivity epsilon depends on the atmosphere's opacity cocktail. At a few hundred Kelvin, collision-induced absorption in H2 turns the spectrum into a low-contrast IR psi, and helium coats remix the vowels but keep the sentence the same. Less. Transport inside plays relay. Fact: degenerate electrons conduct heat with a conductivity kappa that makes copper blush. Ions contribute little once they're locked into a lattice. Punchline: the star is a space-grade frying pan with a stubborn nonstick layer. Move: as T falls, electron-phonon scattering weakens, kappa rises, and temperature gradients flatten until the whole interior shares one opinion about being cold. Phonons handle what's left of personality. Fact: in a Debye solid at low T, the heat capacity C_V is proportional to T/θ_d. Superscript 3 and phonon mean free paths grow, strangling the number of ways the lattice can hold warmth. Punchline: The crystal forgets how to keep secrets. Move. With fewer vibrational modes awake, each Kelvin of cooling needs more time, and the isothermal core becomes a monastery where only the quietest chants survive. Non-equilibrium still has rules. Fact. Detailed balance tells transitions occur forward and backward with rates tied by Boltzmann factors. At vanishing T, upward moves starve. Punchline. Life gives you lemons. The lattice files a lemon-related rate equation. Move. Defects, vacancies, interstitials, dislocations. Migrate by tunneling and activated hops. Every relocation increases microstates and sprinkles EV of heat that conduction smuggles to the surface like contraband warmth. Information gets a bill too. Fact. Landauer's principle says erasing 1 bit costs greater than or equal to k_bt ln2 of heat dumped somewhere. Punchline. Forgetting is warm. Move. The black dwarf isn't a computer, but any internal memory. Domains, trapped charges, metastable arrangements. Relaxes with the same thermodynamic toll, and the toll booth never waives fees at microkelvin. The bath keeps moving the goalposts. Fact. The ambient temperature is not static. The cosmological background cools with expansion, and if dark energy holds steady, the de Sitter horizon carries its own temperature T_H is almost equal to H/2 pi K_B. Punchline. The universe installs a space heater set to ridiculously low. Move. Once the CMB redshifts beneath T_H, the horizon's faint glow becomes the true floor, and your dwarf must negotiate with a bath that refuses to be zero but happily approximates it with 30 decimal places. Kirchhoff won't let you cheat. Fact. Emissivity equals absorptivity at each frequency. You can't be a great emitter without being equally great at soaking up the same color. Punchline. No coupon for selective radiators. Move. As the background spectrum slides to longer wavelengths, the object's ability to absorb from it pins the last steps of cooling. Radiative balance becomes a chess match with pieces that move once per geological library. Microscopic bookkeeping keeps paying pennies. Fact. Superscript 2 sedimentation in a CO lattice continues releasing gravitational energy, while the heavier isotope diffusion sneaks downward over absurd epochs. Punchline. The dwarf practices geology by rearranging 2% of itself. Move. Phase separation during further solidification squeezes an extra dribble of heat from the gradient in charge to mass. It's tiny, but tiny is all that's left, and tiny doesn't miss deadlines. Convection refuses to fully retire. Fact. Once the outer envelope becomes convective, surface cooling is gated by how quickly the top few scale heights can overturn and dump heat. Punchline. The star keeps stirring a soup you'd need an electron microscope to taste. Move. Magnetic fields can suppress or channel that overturn, creating patchy photospheres where local entropy leaks argue in accents, then report to the same cold embassy. Radiative transfer gets weird at the bottom. Fact. At centimeter-to-meter wavelengths, refractive indices, free processes, and CIA define the opacity slope, bending the emergent spectrum away from a tidy blackbody. Punchline. The light curve dresses in off-brand. Move. Those low-frequency tails carry the last power out. Alter opacity by a few percent, and the time constant T_cool shifts by swaths of "you will not live to see it," which is fine because nothing else will either. Fluctuation dissipation keeps whispering. Fact. The same microjiggles that create noise control how systems relax. At low T, spectra of noise go 1/f-ish or freeze out depending on the mode. Punchline. Even silence has a soundtrack if your mic is patient. Move. The star's thermal noise sets the cadence for defect hops and local rearrangements. Each act of dissipation is a receipt stapled to entropy, and the stapler has infinity staples. Gravitational entropy is the odd cousin. Fact. Self-gravitating systems can heat when they lose energy, negative heat capacity. But degeneracy dodges that circus by divorcing pressure from temperature. Punchline. Quantum mechanics takes away gravity's favorite party trick. Move. The dwarf cools without collapsing, holds radius without drama, and watches gravitational degrees of freedom exit through long-ago winds, tides, and the distant appetites of black holes. Free energy gradients dwindle, but don't vanish instantly. Fact. Any residual chemical potential differences, carbon/oxygen zoning, trapped impurities, tiny charge imbalances, equilibrate on diffusion clocks that make stalagmites look urgent. Punchline: the crystal is a perfectionist working overtime on a sculpture no one will see. Move: every relaxation feeds heat outward. Every outward photon lands in a bath just a hair colder than the source. Every hair gets split until even metaphors need mittens. Even 0 point isn't a loophole. Fact: the lattice keeps non-zero vibrational energy at T0, but 0 point cannot be drained. It's the ground rent of the quantum building. Punchline: you can't pawn the vacuum. Move: what you can drain is the distance between your current ensemble and the ground state. Defect by defect, the crystal walks downhill in a staircase of improbable steps that time makes inevitable. The last sources of structured motion look parochial. Fact: tidal kneading from late flybys, minuscule accretion shocks from dust, and micrometeor strikes all thermalize into the same pot. Punchline: the universe throws pebbles at a freezer. Move: each event is a pixel flash on a screen dimmed to theoretical. Conduction wipes it smooth. Entropy tallies the score and yawns in a way that sounds like physics when you slow it down enough. All of this obeys the simplest sentence in nature. Fact: ds_universe equals ds_star plus ds_bath 0. With equality only if nothing happens and nothing always loses to something. Punchline: the second law is the only influencer that never pivots niches. Move: a black dwarf's thermodynamic arc is just the Xeno-like approach of a finite store of order toward a background that keeps lowering its bid, mediated by transport coefficients that grow, capacities that shrink, and barriers tunneled one insult at a time. In the lab, the model's flux ticks into numbers that prefer exponents to digits. The power spectrum slouches into wavelengths where detectors become philosophy. The free energy ledger approaches a silence that's still busy, and the horizon temperature keeps its unhelpful smile. The crystal, meanwhile, keeps rearranging at a pace that tortures clocks more than patience, and somewhere in that slow motion a new question elbows onto the spreadsheet. The kind that asks what you can even measure when light is a failed strategy and heat is a rumor you verify with a better rumor. We point the biggest telescope at the coldest corner of the sky, and it returns a high-resolution portrait of tasteful nothing. Fact: a true black dwarf radiates so little that its spectrum hugs the microwave floor and then apologizes. Punchline: it's a nightlight for ants in mittens. Move: detection becomes an art project where you chase absence with instruments built to catch presence, and the grant summary reads like haiku: 5 syllables of hope, 7 of physics, 5 of no. So we cheat with time. Fact: we can't see black dwarfs, but we can map their ancestors. White dwarfs, cooling through space like embers losing the argument. Punchline: paleontology but for light. Move: astrometry missions pin distances to microarc seconds, turn colors into temperatures, and lay out a cooling sequence on the color magnitude diagram that looks like gravity's cursive. Where that line bunches up at certain luminosities, something slowed the cooling clock. That something is physics waving from inside the star saying, the crystal just clicked. Astroseismology offers the stethoscope. Fact: some white dwarfs thrum with non-radial G-modes whose periods depend on stratification, composition, and how much of the core has frozen. Punchline: we diagnose dead stars by listening to their shivers. Move: fit the pulsation spectrum and you retrieve core oxygen fractions, envelope thicknesses, and an estimate of the solid fraction like a radiology report that smells faintly of helium. Spectroscopy brings the makeup wipes. Fact: surface gravity so high that metals shouldn't float. Yet we see calcium, magnesium, iron in some atmospheres. Punchline: crumbs on the couch. Someone's been snacking. Move: those polluted dwarfs betray ongoing accretion of pulverized asteroids, which sets limits on how insulated the surface is, how heat leaks, and how long a relic can keep its complexion while debris rain writes graffiti in absorption lines. Infrared surveys stretch for the dimmest glow. Fact: cool white dwarfs shove their flux into the near IR and then the mid-IR as they age. Below a few thousand Kelvin, they start playing hide-and-seek with detector noise. Punchline: astronomy by Braille. Move: stack exposures, model collision-induced absorption, and you can track the tail end of the cooling track without pretending you saw something that wasn't there. Every extra data point narrows the road toward invisible. Microlensing offers the ghost fingerprint. Fact: a compact, dark object can bend background starlight, brightening it for weeks to months with a time profile that smells like gravity. Punchline: photobombing by mass. Move: surveys catch these events and, with a decent parallax, can estimate lens mass without seeing a photon from the culprit. Pile enough events and you can census the remnant population, though sorting dwarfs from black holes is a hobby that eats weekends. Kinematics whisper the ages. Fact: older stellar populations wander with larger velocity dispersions. Cool white dwarfs with big space motions likely belong to ancient cohorts. Punchline: your grandparents drive slower, their stars don't. Move: combine proper motions, radial velocities, and cooling ages to reconstruct star formation history, which doubles as a forecast for how many embers are queued for the transition to "you'll never see me again." Clusters make clean laboratories. Fact: in a cluster, stars form together, so the white dwarf luminosity function's faint cutoff clocks the time since birth. Punchline: the universe's punch-out card. Move: that cutoff slides with age, crystallization stalls add bumps, and the whole curve lets you calibrate models that will, much later, be the only map we have to a world where maps are theories and landmarks are equations. We test opacities by trial and error and bruised egos. Fact: the coolest hydrogen atmospheres look paradoxically blue in optical bands because H2 collision-induced absorption drags flux out of the near IR. Punchline: the oldest dwarfs catfish your color cut. Move: build atmospheric models that respect that quirk, fit photometry, and you claw back truth from filters that swear you're wrong with confidence. Magnetism tries to confuse the jury. Fact: megagauss fields split spectral lines, smear continua, and can spoil convection. Some dwarfs go quiet in pulsations once fields get uppity. Punchline: nature added a magnet and told you to just model it. Move: decoding those spectra refines surface gravities and temperatures, and those feed the cooling ages. Every % of accuracy in the bright world echoes down the hall to the dark one. The cosmic background sets the floor we can't sweep lower. Fact: today's CMB sits at 2.725 K. Tomorrow sits lower. Instruments drink liquid helium and still sweat. Punchline: we built cameras colder than your ex's texts, and the universe still said colder. Move: any claim of detecting subroom temperature dwarfs has to outrun backgrounds from dust, zodiacal light, instrument glow, and the steady hum of everything that isn't your target but insists on being in frame. Gravitational waves lift another corner of the rug. Fact: double white dwarfs chirp in the millihertz band while they inspiral. Mergers warm cores, reshuffle crystals, and sometimes tip masses toward fireworks. Punchline: cosmic ASMR with consequences. Move: count those binaries, project merger rates, and you set expectations for how many relics took the detour through violence rather than the highway through boredom. Each branch alters how many embers survive to attempt invisibility. Neutrinos already filed their resignation, but we checked anyway. Fact: hot dwarfs dump energy through plasmon decay neutrinos, cool ones don't. Punchline: a heat leak that you can't plug and can't measure directly unless your detector is a star. Move: by matching early phase cooling to models with and without that channel, we calibrate the slope heading into the regime where only photons matter, because later you won't get a second chance to fix the math. Population synthesis plays SimUniverse responsibly. Fact: feed a stellar initial mass function, a star formation history, and metallicity evolution to a code. Out comes a remnant census with ages, masses, compositions. Punchline: Monte Carlo but sentimental. Move: pit those predictions against real counts from surveys. When they line up, you trust the trajectory beyond the last pixel and write black dwarf on the horizon with pencil that physics won't erase lightly. And we still run into the brick wall named sensitivity. Fact: below a few hundred Kelvin, a dwarf's peak moves to tens of microns through millimeters, where telescopes are allergic to atmosphere and budgets. Punchline: you want a space observatory the size of a principality. Move: until you build it, You infer by absence, triangulate with lensing, and read the fingerprints that crystallization left on cousins you can see, because triangulation beats staring. Which leaves the practical question. If darkness wins the brightness war, what do you use for reconnaissance? Mass that bends, timing that rings, or heat so faint you count it in metaphors? The screen shows a cooling track tapering into numerical fog, the microlensing event list ticking like distant rain, and astroseismic fits nudging composition to decimals that remember their place. And somewhere beyond those decimals, the next constraint is hiding in a measurement that refuses to be a photon, but still insists on being a signal. We dim the lab screens until the only light left is the cursor blinking like a heartbeat that refuses to pick a tempo. Fact: the universe's soundtrack trends toward silence because free energy dries up, not because physics runs out of verbs. Punchline: the score didn't stop, the orchestra sold its instruments. Move: without gradients to exploit, grandeur downsizes into bookkeeping. Entropy keeps the books, and everything else quietly pays dues. Perspective does most of the heavy lifting. Fact: our era sits between two darks, one before stars, one after warmth, like a lit hallway in a building that was never zoned for parties. Punchline: we are the hallway decor. Move: for a few billion years, nuclei bought brightness by fusing. For far more, crystals will rent space to memory and let it fade by conduction's polite efficiency, and the timeline makes our anxieties look like sugar highs. Meaning survives even when glow doesn't. Fact: degeneracy pressure is quantum mechanics enforcing personal boundaries on electrons. Punchline: the final architecture is held up by a rule about seeding charts. Move: star birth and death feel operatic. The endgame is a lesson in policy. Pauli says no, gravity says please, thermodynamics says pay, and the result is a cosmos that prefers contracts to confetti. Even poetry has to file forms. Fact: the same equations that give you rainbows and rainstorms also hand you a crystal that tries not to emit. Punchline: Maxwell and Boltzmann wrote the love letters and the restraining order. Move: it isn't nihilism, it's scope. Physics can give you nebulae shaped like butterflies and later insist that butterflies become rocks with excellent crystal lattices, and those two moods live in the same law set without apology. Legacy shows up in what's measurable. Fact: the periodic table's middle was minted by stars that later became the dark furniture of galaxies. Punchline: every iron atom in your blood is a souvenir from an engine that eventually filed for retirement. Move: biology borrows energy differentials. Culture rides on surplus. All of it is a side effect of a universe that briefly tolerated bright wastefulness before returning to disciplined austerity. The whisper is not a lack, it's a register. Fact: low power channels, microlensing curves, gravitational murmurs, thermal relics are still signals. Punchline: the universe switched from theater to podcast. Move: with brightness gone, curvature and timing carry stories. A lens bends a background star by 1%. A compact binary chirps across emptiness. A faint heat bump betrays ions choosing a lattice over a liquid, and each clue is a breadcrumb that refuses to glow. You don't need apocalypse to get purpose. Fact: entropy increases whether we compose symphonies or stare at ceilings. Punchline: the second law doesn't review art, it counts microstates. Move: meaning is local and contingent. Systems that can metabolize gradients can also write epics, turn them into data, and lose them again, and that loop is not an error. It's how chemistry caches cosmic checks. Even the quiet contains dynamics. Fact: horizons in an accelerating universe carry a temperature. De Sitter space hisses at TH/2 π_b with the enthusiasm of a freezer that hums when no one's around. Punchline: emptiness keeps a night light. Move: that bath sets the last room tone for crystals to cool against. A floor so low it turns ambition into statistics and statistics into patience. Scale breaks intuition, then rebuilds it. Fact: numbers like 10 superscript 1 years or 10 superscript 1 years aren't big, they're categories. Punchline: our metaphors retire long before the stars do. Move: on those scales, rare wins, tunneling events, slow decays, improbable captures, accrete into certainty, and certainty doesn't wear fireworks. It wears inevitability stitched one microprocess at a time. Cosmic history is a sandwich with thin bread and extravagant filling. Fact: the dark at the start and the dark at the end outweigh the visible by absurd margins. Punchline: we live in the fancy middle smear. Move: that smear inscribed galaxies, planets, and complaints about Mondays onto a space-time that was content to be quiet both before and after, which makes the complaints feel both charming and very temporary. Still, the laws are generous in their predictability. Fact: you can write down the Einstein field equations, the quantum statistics, the transport coefficients, and predict a world that cools. Punchline: fate as a differential equation. Move: determinism here doesn't flatten wonder. It frames it. Knowing the script doesn't cheapen the performance if the cast includes entire galaxies climbing and falling through an HR diagram like climbers on a glass mountain. The legacy isn't that light dies. It's that structure had a chance. Fact: turbulence carved filaments, gravity gathered halos, feedback carved pockets, fusion burned maps into chemistry. Punchline: the universe made complexity with spare change. Move: complexity paid back by radiating entropy, and the receipt is written across the CMB, the metallicity of stars, the debris around dwarfs, and the chemistry that accidentally invented questions. Ethics even sneaks a cameo. Fact: every civilization is a heat engine with opinions. Punchline: morality with a power budget. Move: the limits aren't moral sentences, they're boundary conditions. Free energy limits how long insight can be embodied, not how illuminating insight can feel while it's embodied, and that distinction matters if you're deciding what to do on a Tuesday. The silence will not be empty of memory. Fact: patterns persist as long as energy barriers hold. Crystal domains, defect maps, orbital debris, black hole demographics. Punchline: history curates in materials science after the museums close. Move: those patterns relax, smear, and dissolve into coarser summaries. Mass here, curvature there, background everywhere, and each relaxation is a flick of heat that whispers, "This used to be sharper." Even the word end is a human accent. Fact: physics cares about boundary conditions, not finales. Punchline: the cosmos writes continuations, we title chapters. Move: what happens is not a curtain but a limit. The slope of luminosity approaches a line you can name quiet, and the line keeps receding while objects chase it with discipline that looks like stillness from far away. Stand in that quiet and inventory what stayed true. Fact: conservation laws held. Symmetries broke where they were told, curvature answered mass, quantum rules enforced manners. Punchline: the universe followed instructions without reading the mood. Move: those same laws gave rise to laughter inside a primate cortex, and somehow that noise is part of the ledger too, because heat released by a joke still warms the room a little before it leaks into space. So what do you do with a future written in lowercase? Fact: legacy is not a monument. It's a transfer function from gradients to patterns to recollections. Punchline: everything meaningful is a heat-powered stencil. Move: the stencil persists as long as energy flows, and when it stops, the stencil joins the archive as entropy, which sounds like loss until you realize the archive is everything and the card catalog is physics. The cursor still blinks. The lab is quiet enough to hear coolant tick, a small kindness pretending to be weather. Somewhere, a crystal star chooses a new defect path. Somewhere else, a horizon breathes a temperature with bad social skills. Between those two somewheres sits a brain that can count to 10 and still wants to ask why the silence matters, which is a useful itch, because it scratches at the one gradient we haven't priced in yet, the one that turns curiosity into work and work into heat and heat into stories. And that gradient hasn't run out while the question keeps leaning forward.